Here's a paradox that's breaking the tech industry. AI tools like ChatGPT have made building prototypes easier than ever before. We're talking near zero cost to create something impressive. But here's the twist. The cost of actually shipping those prototypes to real users, it's skyrocketing.
Welcome to the Innovation Valley of Death, and it's getting wider every day. I'm Will, and you're listening to Mindcast, where we decode the big ideas shaping our digital future. Today, we're diving deep into one of the most critical challenges facing software innovation right now. And I promise you, by the end of this episode, you'll understand why the very tools that were supposed to democratize coding might actually be making things worse. And more importantly, how a new approach called agentic AI could be the bridge we desperately need.
So, let's start with a story. Imagine you're a developer at a startup. You have this brilliant idea for an app. You fire up ChatGPT, describe what you want, and boom, in 30 minutes, you've got a working prototype. It looks great, it demos beautifully, and everyone's excited. But then reality hits. To actually ship this thing to real users, you need security. You need it to handle thousands of concurrent users. You need proper testing, documentation, monitoring. And suddenly, your 30-minute prototype becomes a 6-month engineering nightmare.
This is what researchers call the Innovation Valley of Death, that treacherous gap where promising prototypes go to die. And here's the kicker. AI hasn't eliminated this valley. In many ways, it's made it deeper. We've entered the era of what I like to call vibe coding, rapid, prompt-driven development that prioritizes getting something working over building something sustainable. Think about it like this. Imagine if 3D printing made it incredibly easy to create a car prototype, gorgeous exterior, all the right curves, but you still had to hand-build the engine, transmission, and safety systems. That prototype would look amazing in the showroom, but it would be completely unusable on real roads. That's exactly what's happening with AI-generated code right now. So why is this happening? Well, it comes down to 3 types of debt that accumulate in software projects. And I don't mean financial debt. I mean technical debt, innovation debt, and a brand new category that's emerged with AI, comprehension debt. Let's break these down, because understanding them is crucial to grasping why so many promising projects fail. First up, technical debt. This is the classic killer. It's what happens when developers take shortcuts to move fast. They hard code values instead of making them configurable. They skip writing tests. They ignore security best practices. In the rush to build a demo, they create what researchers colorfully call cruft. Code that works for now but becomes increasingly fragile and unmaintainable over time. Here's a great analogy. Imagine building a house but skipping the foundation because you're excited to see how it looks. Sure, you can get the walls and roof up quickly, but the moment you put any real weight on that structure, like actual furniture or, heaven forbid, a second story, everything comes crashing down. That's technical debt. It accumulates interest in the form of slower development and higher risk of catastrophic failure. Then there's innovation debt. And this one's more subtle, but equally dangerous. This is when organizations fail to evolve their processes and thinking. They might have cutting-edge AI tools, but they're still using outdated approval workflows that take weeks instead of hours. They're stuck in solution-first thinking instead of problem-first thinking. The prototype dies, not because of technical issues, but because the organization literally cannot move fast enough to capitalize on the innovation. But here's where things get really interesting, and this is the new kid on the block. Comprehension debt. This is uniquely an AI problem. When a human writes code, they build a mental model of how the system works. But when AI writes code and a human just accepts it without understanding it, that mental model is completely severed. Developers end up with sophisticated code that they can't debug, modify, or secure because they don't actually understand what it does. This creates what researchers call the productivity paradox. Individual developers appear more productive, they're shipping code faster than ever, but organizations actually become less effective because when bugs inevitably surface during production deployment, nobody knows how to fix them. It's like having a Ferrari with the hood welded shut. Impressive performance until something breaks.
Now, if you're feeling a bit overwhelmed by these problems, I get it. It sounds like AI has created more problems than it's solved. But here's where the story gets exciting because there's a solution emerging that could completely transform how we think about software development. It's called agentic AI, and it represents a fundamental shift from AI as a passive assistant to AI as an autonomous engineering team.
Let me explain the difference. Right now, most people use AI like a really smart co-pilot. You give ChatGPT a prompt, it spits out code, and you copy-paste it into your project. That's passive AI. Agentic AI is completely different. These are autonomous systems that can perceive their environment, plan multi-step workflows, execute tasks, and verify their own work. They operate in a continuous loop of action and reflection.
Think of it this way. Instead of having one super smart intern who can answer any question but needs constant supervision, you have a team of specialist agents, each with specific roles and responsibilities, each capable of checking the other's work. The key pattern here is called planner, executor, validator, and it's revolutionary.
The planner agent acts like a senior architect. It takes your high-level request, let's say build a user authentication system, and breaks it down into specific, measurable subtasks. It defines acceptance criteria and maintains a clear project roadmap. Crucially, it never touches the actual code, so its strategic vision stays pure.
The executor agent is like your senior developer. It picks up individual tasks from the planner and actually writes the code. But, and this is important, it's constrained by strict system prompts that enforce coding standards. It has to write tests first, follow security best practices, use proper naming conventions, and if it gets stuck or fails after a set number of attempts, it escalates rather than spinning in circles forever.
Finally, the validator agent acts like your quality assurance engineer. Before any code gets committed, the validator reviews it against the acceptance criteria. It runs the full test suite, checks for security vulnerabilities, verifies that nothing unrelated was modified. Only when the validator gives approval does the code make it into the main branch. This completely eliminates the comprehension debt problem because every piece of code is automatically documented and verified.
But the real magic happens when you realize these agents can also handle all the boring but critical tasks that usually kill prototypes. They can automatically generate infrastructure as code to deploy your app to the cloud. They can set up monitoring and alerting systems. They can even perform automated security testing, essentially having AI agents attack your own system to find vulnerabilities before real attackers do.
I want to share a concrete example because this isn't just theoretical. There are companies already using this approach to bridge the valley of death. Instead of a developer spending weeks learning Kubernetes and Terraform to deploy their Python app, an agent can analyze the application, detect its dependencies, and automatically generate all the deployment scripts needed for production. What used to take weeks now takes minutes. But here's where this gets really fascinating, and this is our third key insight. Agentic AI isn't just about making current software development faster. It's about fundamentally reimagining what software development could be. We're moving from human in the loop to human on the loop. Instead of humans doing the work with AI assistants, humans become orchestrators, directing autonomous systems.
Think about what this means for documentation. Right now, documentation is often an afterthought. It gets written once and then becomes outdated as the code evolves. But with agentic systems, you get living documentation that automatically updates every time the code changes. The documentation is always current because the agents that modify the code are the same agents that update the documentation. Or consider predictive maintenance. These systems can continuously monitor performance metrics and automatically optimize inefficient code or over-provisioned resources. They're essentially paying down technical debt in real time before it becomes a problem. It's like having a system that automatically fixes small cracks in your house's foundation before they become structural issues. And here's something really exciting. The role of human developers is evolving, not disappearing. Instead of being code writers, they're becoming system orchestrators and agent owners. They design workflows, set quality standards, and solve high-level problems, while the agents handle the implementation details. It's like the difference between being a factory worker and being a factory designer.
Now, I know what some of you might be thinking. This sounds almost too good to be true. And you're right to be skeptical, because there are definitely challenges. These systems are computationally expensive. They're query machines that can generate enormous loads on databases and APIs. Without proper optimization, the operational costs could exceed the cost of human developers.
There are also new security considerations. Agentic systems introduce novel attack vectors like prompt injection, where malicious inputs could manipulate the agent's behavior. And because these systems can operate autonomously, traditional security auditing becomes more complex. But the good news is that these challenges are being actively addressed through techniques like zero-trust architectures for agents and automated security testing.
All right, let's bring this all together with 3 concrete takeaways you can act on whether you're a developer, a tech leader, or just someone trying to understand where this industry is heading.
Takeaway number 1. If you're working with AI-generated code right now, start implementing what researchers call spec-driven development. Instead of jumping straight from idea to code, force yourself to write a detailed specification first. Define what success looks like, what the edge cases are, and what the security requirements are. This single practice can dramatically reduce comprehension debt and improve the quality of your prototypes.
Takeaway number 2, start thinking about roles and responsibilities. Even if you're currently just using basic AI tools, try to separate the planning from the execution in your workflow. Use AI to help break down complex tasks into smaller, well-defined pieces before using AI to implement those pieces. This mental shift prepares you for the more sophisticated agentic systems that are coming.
And takeaway number 3, start experimenting with validation and review processes. Whether it's automated code review tools or just being more systematic about testing AI-generated code, begin building habits around verification. The future belongs to those who can trust but verify, and that verification increasingly needs to be automated to keep pace with AI-generated development.
Here's the bottom line. The innovation valley of death is real and is getting wider. But for the first time since software development began, we have tools that can systematically address the root causes, the technical debt, the innovation debt, and the comprehension debt that kill promising prototypes. Agentic AI represents more than just better tools. It represents a fundamental shift in how we think about building software. We're moving from a world where individuals code faster to a world where organizations ship more reliable, maintainable, and secure software. And that transformation is happening right now.
That's a wrap on today's episode of Mindcast. If this topic resonated with you, I'd love to hear about your experiences with the Valley of Death or your experiments with agentic approaches. Until next time, keep bridging those gaps and turning those prototypes into products that actually ship. Thanks for listening.